Okay. Okay, shall we continue? Okay. Kalau ada line terputus apa, you just inform me, signal me kalau ada line breakdown ke apa. Okay, let me show you in our e-learning we have notes. If you look on my e-learning, there actually I put in this e-learning. You can see the e-learning, right? I put it not in proper order. So actually from here you can look either. The first thing is about your knowledge. As I mentioned to you, you punya fundamental knowledge about static failure, about static loading. So you need to know to refresh your knowledge. So there's a lot of version of notes here, but you can look on it. This one I look on this chapter, static failure prevention. There's a lot of notes like topic load and stress and so on. Okay, let's go for this note. If you look on this note, is here. By the way, in your e-learning, you can see your complete notes in here. In the banner already put there. Yeah, I already put. You have your textbook there. You can download it. And lecture notes here is a zip file. You can look on all chapter is there. Lecture notes. All right. Okay. Class, can you hear me or not?
Yes,
Okay, tapi I put it not in proper. The one that I extract here, lecture note, static, stellar. Okay, if I share is in the slide. If I share you, you can see my PowerPoint. Right. Class just mentioned to you, kita use buku Javinal. Javinal book. Javinal book is hold on, Javinal 6th edition. This buku Javinal. I share to you. Okay, this is our textbook. Javinal already in the, you can download it from e-learning. 6th edition is there. Sometimes the assignment I give to you is from certain chapter from this textbook. For example, like fatigue analysis and static analysis. Sometimes from the one that I attach in the e-learning. Okay. So this is a Javinal textbook. Javinal textbook, at the end, we have a lot of tables, your table property, and because you always refer to your table properties in terms of the strength of your material. Macam for example, like in your appendix. In appendix, you have table properties of material. Hold on, appendix A, you have table properties. Where is it? Macam ni, you have all the kind like deflection properties. You will refer to this later, like table properties of material. What is the SY? What is this? Dia punya SU? All these table properties. Mechanical property. Because for example, like when you select design shaft, what material of shaft that you use, then you need to refer to dia punya yield strength. Maybe dia punya ultimate strength, SU. This one I will explain. Tensile strength, SU. Or maybe lead strength, depend on the material that you select. Okay, and all the content of your textbook is what from our syllabus lah. Okay, from static analysis, fatigue analysis until gears, okay, shaft analysis, bearing, and pulley and belt. Tetapi kita tak cover all the chapter in the textbook. Kita in our course content that I explained to you previously is kita extract yang the main important on the topic only. Kita tak cover everything because in this textbook is complete. We have a lot and another of machine component like a clutch plate, rope and brake system ada. Kita tak go on that. Even the gears they have bevel gear, worm gear. Kita tak go for that gear. Kita go for super gears on. Okay, just mention to you, textbook already there in your e-learning. Okay, it's on in your e-learning. E-learning ada. Alright. Okay, let me share you the notes that I cakap tadi static. Alright. Ni notes ni PowerPoint ni boleh nampak
boleh.
Boleh Right. Okay, kita punya first ni is about design of mechanical failure, static failure. Okay, I need to explain to you a little bit. Okay, the first thing in your machine component design, because in design kita ada static failure or fatigue failure normally. Static failure or boleh dengar line tak ada tak clear kelas?
Boleh.
clear.
Okay, kita dan in design we have two type of failure, either static failure or fatigue failure as I mentioned. It depends on you punya design component lah. For example, if your component tu is a static loading only, for example, ada cakap a bracket supporting a static load. For example, kita cakap macam you punya bracket supporting a TV or supporting any kind of loading. Macam you have a system or mechanism component that support loading, but the loading is static. It's not movable punya load, not variable. The loading to remain constant, that we call static. That mean the load is not changed. So the load remain constant through times. It will not change. You don't have maximum value, minimum value, atau you cannot alternately positive and negative side. No, it's just a static loading. For example, a lot of component is static loading. Macam the chair you are sitting on, for example, kind like static loading. Any kind of structure that support load, and the load, for example, like a bracket holding a TV or something like that. That bracket to support static load. Okay, certain. Okay, we have to type either static failure or fatigue failure. Fatigue failure, it means when the loading is variable. Itu fatigue, F-A-T-I-G-U-E, lesu. Fatigue failure. Itu later on, that is will be your chapter, another next topic lah. Kita first topic ni is about static. You have already learned the fundamental kan. When static loading, you kena tahu lah force analysis, and from force you can get the stress and so on. Okay. Okay, if you look on this slide, okay, boleh nampak slide So I skip through this one. Okay, boleh nampak slide ni guys?
Something is blocking. Grey color box.
You can see my PowerPoint.
Can see, but a grey color box is in the middle.
Okay, let me.
It's gone, sir.
Can you see now? Can you see my
Clear,
PowerPoint?
doctor. Clear.
Okay, you punya fundamental lah. First thing you gonna know lah, you learn from your static, summation of force equal to 0, summation of moment equal to 0. And when you learn dynamic, summation of force equal to Newton's second law, and force equal to mass time acceleration. And the other one is summation of moment equal to I time alpha. Alpha is angular acceleration, right? I is the what? Moment of inertia, I. Again. Apa tu? Itulah this kind of ni summation of force, summation of moment equal to 0. So you kena tahu of this equilibrium. Okay, this itulah the fundamental you kena tahu. Like forces have three component of forces. Force to we have force in term of this one is right hand rule, you kena tahu direction of F apa tu? You punya Fourier diagram tu, you kena forces tu can be in term of direction of X, Y, and Z. And also you have to know dia punya direction of your what we call it moment and torque. Moment and torque. Moment and torque tu is actually your force time distance. Time distance is moment, and also we can call it torque. But the direction of tu is you punya right hand rule. You punya the direction of your torque tu is you kena tahu kan. Sekejap. Boleh nampak video Can you see my live video? Okay. You learn from you punya summation of fx equal to 0 can. static summation of Fy must be 0. Summation of your Fz equal to 0. Depend on how you axis. Sometimes certain buku, this is X, this is Y. Ada certain book Z pointing up. Ada certain book like this. Macam Gervinal, you use Gervinal, dia X is like this. Kalau American, dia banyak like this. Y is like that. Dia punya Z pointing like this. So equilibrium, it means your summation component of your Fx, if you add up together component of X, it must equilibrium. Summation Fy equal to 0. Summation of Fz. The Z is like this. Depends. This thing we're talking about force. When we are talking about okay, sorry kelas, line putus dengar kelas. Yeah, can you hear me? Okay, the line breakdown. Okay, this is a summation of force. And what is moment? What is moment? Okay, you know what is force, right? You have problem with force, summation of force. So what is direction of moment? What is moment? Okay, for example, you have a body, right? This is your body, and you have a force, and this is your CG. What is moment? Moment is what? This is force. The distance, right? Perpendicular distance, betul tak? Moment or torque. What is moment? Moment is F time distance. Betul tak? Class, are you listening or not? Okay, this is your centroid, the distance. This is direction of your force. So what is direction of moment? Are you listening or not? Can you hear me? Okay, moment, okay, this is counterclockwise. What is the vector direction of your moment? Okay, this will produce moment on this CG, right? On this free body diagram, this body. This is moment, the turning of your moment, right? Moment is force time the distance. So what is the vector of the moment? What actually that vector of the moment? Yeah?
Towards the camera.
Right hand rule. Can you see my hand? If the moment produce counterclockwise. Can you see the wrap of my finger is counterclockwise? What is the direction of my? This is right hand. We're not using left hand rule, right hand. The direction of my thumb. So the direction of your moment, the vector direction of your moment or your torque. Torque also we can say the torque. It depends on the situation. Torque, T, or torque. Torque is force time distance also. Can force torque also. Or moment, it depends. Right. Direction of torque, direction of moment is if the rotation of the moment is like this and the direction is your thumb. So that's what I call that. The direction. For example, if you rotate of your moment like this, so your thumb is a positive moment. Let's say positive X. Let's say this Y, this is Z. If this is a positive moment on X. If your right hand rules, if the direction of your moment like this is pointing up. So okay, in terms of Y, so it means the direction is of your moment turning like that. So it means it's pointing, vector moment is on positive Y. For example, like if you're turning like this, direction is like this. So it means the direction of your moment is, if turning like this is, okay, and this one is MY positive. This one is MZ. Do you understand what I'm talking about? Class? Hello? Can you hear me or not?
Yes, doctor.
Yeah, that means the direction vector of the moment. That's what I'm explaining to in terms of this thumb. The direction of your free body diagram. Summation of force into summation of moment also must be 0. And just to mention to you again, summation of moment. Just to mention to you again, if you look on my summation of not just Fx, Fy, Fz must be 0, and also your summation of when we talk about summation of moment X also must be 0. Summation of moment Y must be 0. Summation of moment Z must be 0. That's what you call it. And also summation of torque. Do not confuse. Sometimes we call it torque. It depends on the situation. summation of top y equal to 0, summation of top z must be 0. That's what we call equilibrium. This is static equilibrium. For by dynamic, you know F equal to MA. Dynamic little bit lah. Sometimes kita more focus on static equilibrium, but sometimes it apply also when you involve with dynamic, like summation of F equal to mass acceleration. What we call it is apa tadi from the notes tadi, summation of moment equal to force, summation force equal to MA kan, Newton's second law, and apa tu summation of force in dynamic equal to mass time acceleration, summation of moment equal to I time angular acceleration. This one is more dynamic analysis, right? Accelerating body. If you are in accelerating body, okay. But in normally machine component design, we don't involve that machine element or power transmission. We don't involve in accelerating unless we are doing automotive when you do when your body accelerates. But normally we are in constant motion, so kita not focus much on this. Kita more on equation of force and moment and torque equal to 0 in our component design. Right. Okay, let me share you again the slide. Okay. Boleh nampak the slide, itu ada. So I'm talking to you. Okay, if you look on this slide, we have kalau tak nampak, beritahu saya, minta maaf about this thing. Boleh nampak my slide ni? So yang cakap tadi about di itulah you punya yang ni macam okay, another thing is about your free body diagram you kena tahu. Pasal in component design, first kali involve your free body diagram. When you do analysis, when you do assignment, normally you write what is the given question, what you want to find, then kemudian follow by your schematic diagram, your free body diagram first. You must sketch the free body diagram. Because the free body diagram is you punya fundamental lah, the main thing. Because from the free body diagram, we can find the reaction force. If your free body diagram is wrong, I mean your reaction force is wrong. Okay, suppose the force have two components, you just make just one component and you punya free body diagram is wrong. So you punya force analysis all is wrongly calculated. It's wrong, and when your force is wrong, it will involve your stress calculation also wrong. If your stress calculation is wrong, then you punya the strength of your material also wrong lah. To find the safety factor. Basically design like that. When you calculate force, from the force you can find stress. From the stress in megapascal you relate the strength of that material. So what is the strength of material? You refer to the table. What is the material SY value? Your strength. If the stress that you calculate in megapascal is less than the material SY value, so you mean your component is safe. So that's why if your force analysis free body diagram is wrong, your force analysis is wrong. And then itulah. Kemudian your stress calculation will be wrong. So you punya calculation to find the safety factor wrong lah. It's dangerous lah. So be careful guys. So the main thing, fundamental, your free body diagram is very important. Macam you CV lah, CV 1, CV 2. Kalau you punya one in your primary school kan, CV, what you call CV in English, apa dia? CV 1, your primary school, 1, CV 2, 3 times 1 berapa kan, then only you can proceed to your mathematics is right calculation. Okay, so be careful lah. So in engineering, fundamental lah, let's say your free body diagram must be right. Cannot any single error in your free body diagram. Okay? If free body diagram is wrong, your force analysis will be wrong. Force analysis is wrong, stress analysis is wrong. If stress analysis is wrong, your calculation to find the safety factor is totally wrong. Be careful. So what is mean about joining? Macam all jointing element is about what is dia punya component of reaction built-in support. Kena tahu lah macam ni adalah pin joint. So what is the component reaction? So this is what you learn from static built-in support. Kalau built-in support, fixed support ni apa reaction there? Macam this one free body diagram, this one what itu fixed support. Ni kena tahu lah this thing. So free body diagram tu kena penting. Okay, can you see I share you e-learning nampak Plus.
Nampak doktor?
Boleh nampak kan? Ini saya ada bagi nampak tak image? Can you see this one image? Contoh. Okay, rope, cable. Ini simple lah, saya snapshot ni. Cable, rope, collinear, dia punya what type of support, dia punya reaction force macam mana. Boleh dapat ni, kelas?
Boleh.
Okay, kalau rope and cable, what is dia punya reaction force? This is a free, the right column is a free body diagram. This is what your knowledge from static. I'm trying to refresh your knowledge ni. Kalau you punya this thing is fundamental, you is no good, susah nanti you face problem in this course. You have this rod, the free body diagram. I'm not talking about surface, the member ni, the rod. What we call it, this member, this member. So the surface, nampak tak the surface tu? So dia ada normal to the surface, we have normal force. Pasal dia cakap the surface tu is smooth lah. It's not a rough surface. Kalau rough surface actually is not, we have two component. One is normal due to the friction of the rough surface. But this one smooth. So we only have normal surface. Okay, macam ni we have contact with rough surface. Even ini kita tak go for normal. Normal from ni. Normal mean for smooth surface, it means always perpendicular. You punya normal force perpendicular to the angle of that surface. That what is called normal. Because since it's smooth, we don't have friction. But kalau we have friction like this, a rough surface, dia ada friction. Okay, macam ni of course we need normal is perpendicular. Right. Boleh dengar tak? This normal, but still we have friction. Friction due to the rough surface, ada friction. Careful. Kalau smooth surface, ya, but rough ni. Okay, kalau pin support, pin joint. Pin support, dia punya reaction dia, of course we have AY. No moment, guys. Pin joint, no moment. Some student make mistake. No moment. There is no reaction of moment. Kelas boleh dengar ke? Kelas, can you hear me?
Yes.
Okay, sorry. Line saya putus-putus, sorry. Roller support. Okay, roller support, what is different? Roller support, since they are roller, guys. They are roller. They're not pin joint because the reaction from the roller, they have normal force. So the roller support ni, and something we have landing leg or macam ladam, is kind like what we call it, not wedge. It's kind like sometimes it's a structure. They are supported by the ground by kind like a shoe. A flat like a curvature shoe. This kind like similar like a roller. They actually are rolling. This kind like a normal force. This is not pin joint, guys. Because the reaction from knee to the ground is one component, only straight up. Roller, even they have two roller here, but the total force is just straight up. So dia punya reaction force, kalau tak dengar beritahu saya, guys, just only one. Jangan confuse. Roller support ni bukan pin. Kalau pin support, we have two component, no moment. Roller support only one component, depend on the surface. Understand tak, kelas? Faham tak? Hello, kelas? Roller support dia ni. Okay, kalau constraint and sliding, ini lah constraint. Kalau and reaction to the pin, if you take the ni, you react back to the pin, we don't, if you make, okay, even you make Fx equal to 0, effect, summation of Fx is 0, you get Fx is 0. Memang the roller, because the collar only reaction to the rod surface only normal direction up. So do not get confused. Unless it is not collar, it's a pin joint and you have Fx and Y, Ax or Ay or Ax. Clear? Clear kan? Kalau collar just like that lah. Collar macam tu. Okay. Kalau fixed support, ni fixed support macam you have a beam, hold it, you bolt it or you welded it on the concrete or any member. You have vertical beam, cantilever, and also you have a vertical beam, and you welded and you fix support. Okay, fixed support is not pin support. So fixed support, you mesti ada. We have three components. We have Ax, Y, and moment. Moment on A. Ni be careful. This is what we call free body diagram. Your punya force reaction ni kena betul. Kalau this thing also katakan ini fixed support, you only put only one component, just Ax, totally gone. You punya calculation of your force would be wrong. If force is wrong, your stress punya calculation also wrong. Be careful about it. Okay. Itulah this sample thing. Okay. Kalau let's go for this one. Okay, I give you buat ni. Cepat sikit. Nampak ni guys. 15 minit. Kelas Ali clear sini kau nak? Hello kelas. Boleh buat ni tak? Cuba buat ni. Buat ni. Faham tak? Faham tak question dia? the column ni, okay, this is your force. Okay, dia nak free body diagram, you fill in ni, BC, this member BC. Nampak you ada force. Okay, we're not focus on member A, B ni. We focus on member BC. Okay, remember we have force here. Okay, between member A, B ni, this beam and this beam, they have a roller. Nampak tak? They have a roller at B. And but in BC ni, they have external moment. And at C at the end ada fixed support. B kimpal ni bahasa Melayu. It's welded. Fixed support. So make a free body diagram at BC. Come on, kita discuss. Cepat sikit, apa dia? Macam mana? Boleh share kat sini? Boleh share dekat what's this way back? What I give you sekarang ni buat? Apa reaction dia? Come on, kita discuss in kelas. Come on kelas. Pasal kelas this component design, first thing I need to refresh knowledge about your free body diagram ni. Kalau free body diagram, you problem, habislah. Bukan nak mengancam lah, tapi be careful lah saya cakap PC tu cepat sikit. Line ada terputus apa, dengar ke apa ni?
Doktor nak tengok gambar tadi. Boleh see the picture.
Saya tak share ke ni? Dalam e-learning ni, kan saya share. E-learning ada. E-learning, kau buka e-learning ke? Open your e-learning.
Alright.
Are you open? Do you open your e-learning right now, class? Can you see the picture tu? Hello, class. Class, can you hear me or not? You can hear me, okay? Okay, let's discuss. Kita tak ada masa. Okay, tak apa. I thought I want to give you to do it. Okay, let's discuss for BC ni. Apa dia? Can you see my live video kan? So what is the answer? Boleh share tak? You can share here. You can share you punya sketch. Your free body diagram. Boleh share macam mana? How do you share? Okay, let's discuss. Okay, what do we have here, guys? Tak apa, kita nak save time. Sorry Okay, this member BC. Can you see my live video ni boleh class? Class BC. Dia only for your member BC. Class, can you hear me?
Ya, Doktor.
Okay, at B we have roller, betul tak?
Ya.
Okay, at BC we have external moment is here. Okay, at B we have roller. Kalau roller, what is the reaction for roller to member BC?
BY?
Two component or component of force?
One, I think. One.
One only. The downward or upward?
Downward.
Yes, downward. Okay, force FB lah. We just call it FB lah.
BY.
BY, okay. Good. Kita level pun kena betul lah guys. Kadang-kadang confusing. BY, because since okay, good guys. Kalau you cakap ni Y, yes, it's good you level at this. BY, much clearer lah. Okay, C is what? Pin support or fixed support?
Fix.
Fixed. Kalau fixed kita ada apa? Kita ada?
Fix.
Kita ada C, X, betul tak kan? We have. Okay, CY ni upward or downward? Should be upward lah because since DBY is downward kan, CY. Guys, kalau you put the direction is wrong, it's okay, but the number of component reaction must be right. Nanti when you buat summation fx equal 0 or fy 0, if you get the negative value, it means your direction is supposed to be reverse lah. Okay, what else do I miss? Yes, moment. Since this moment is clockwise, right? So we have counter moment. Oh, sorry. This is clockwise, so we have moment, counter moment at C, counter clockwise. Betul? Alright, clear? Plus. Right. Okay, the second one. We have a rod here, A, B, C, and we have a roller support here. We have a mesh. Okay, macam this like a mesh is like, we call it, I'm not sure it's a roller, but just a mesh. We have mesh. M mean the mesh, not weight. Weight is mass time gravity. Okay. So if this collar, there is supposed to be one component of force, is like this lah, component like this. Or macam mana? Okay, sekarang ni we have a roller here. We have C. So what is the free body diagram here? ABC. Okay. Macam mana kita buat ni? Oh, this one. Okay, member ABC. A, B, C. So what is dia punya free body diagram? Cepat sikit. At A ada apa?
Wait, the weight of the block.
Yeah, you can do some student put it like this lah. The weight of the block kan. AY lah weight of the block. At A tu we have straight lah. Weight. You can do it like this. M times G lah. Since M to the mass. At B macam mana? At B apa? We have
Upward.
normal force. Betul lah kan?
Yeah.
And call it at B. Normal force. Perpendicular to this rod. Betul tak? Because since it's roller kan? One component. Clear tak guys? Plus? Clear tak? B is like this. You don't put two component ni. Kalau if you put two component, you get complicated. You cannot solve the punya force nanti when you do static equilibrium. You want to find the force. Fy0, Fi0, okay? Kelab boleh dengar saya, okay? Line okay? Plus? Right, alright. B is like this, normal force, perpendicular. Okay, what about C? Rough surface. This is called rough surface. It's not smooth surface. What about C? Remember, we have two, yes, C, X, and I call it because this is X direction and reaction. Okay, since the weight, if you look, the weight ni try to macam like, okay, let the roller to kind like the punya fiber, right? The weight try to push it down. The end rod, the right hand rod try to move upward, right? Try to move upward. Tak, it's okay if you go either direction, friction down or up is okay. When you go for Fy equals 0, you got the negative value, it means you punya direction should be reversed. Okay, it's okay, never mind. Tapi logically lah, should be upward or downward, the direction of the friction, because it is a rough surface. Yeah, because the weight tried to turn like this, it tried to topple like this, right? To swing like this, wing like this. Yeah, you are right. So it should be subversion to be down. It's okay. Kalau you put it upwards, okay. When you do calculation, when you Fy equal to 0, you get negative value, I mean, should be reversed. Understand? So this is a free body diagram. Okay, quick one. Okay, what about this one? This one, ABC. We have pivot. This one is pin joint. We have a spring, spring like a rope, just a spring, one component only, just straight direction. This one also we have a rod, just a string, just one straight direction. And we have M is a mass. Weight is M times G, because force is weight, right? Force is mass times gravity. So this, and you learn from mechanical solid, the tension of this rod actually is mass times the gravity. So what is the free body diagram of this one? ABC. So this ABC. Apa dia? Okay, A, what do we have at A? Can you see my color value? Boleh nampak kan? A ada apa? Class P. Pin joint apa? Class. Dia ada apa? Hello. Can you hear me, class? A ada what's the reaction at A? Pin joint. We have A, Y. Direction, no, guys. Do not worry. Direction, wrong, okay. But the number of component must be right. Clear? Okay? When you find fx equal to 0, you will get negatively, it means your direction is reversed. You learn, no, you know this, right? Okay, B, what is it? B, okay, B logically, like, is it downward or upward? B is just one direction component because it's like spring, like a string, a tension, right? It should be like that, spring. Logically, it should be downward. Just a one straight one component should be downward because the mass is pulling, and the spring is kind of like tension or in compression based on the system.
Tension.
Is it the spring in compression or in tension?
Compression.
Macam mana dia tarik, dia compression ke tension ya. Pasal pulley they have mass, they are pulling and the seal will going up, but it's holding. It's okay kalau direction. Okay, you cakap apa? Down, so it's supposed to be downward or upward. Okay, sorry. It's already mentioned here. The spring in tension What is it in Malay? Spring in tension. So spring in tension means what? Spring in tension so be downward By because this is y direction Okay, by spring in tension is not in compression. So tension means is pulling, but spring in compression is because in compress. So the spring try to push it upward, but now spring is pulling in tension, so it's pulling downwards. And C is the direction of the rope, and the tension of the rope here is M times D. Okay, clear guys? So this one is 60 degree. Okay, so you can solve. The point is you can solve the force here, then you can calculate which point, you can calculate the stress, and the stress you can know the safety factor. Safety factor is the stress on that point over the strength. What is strength? Refer to the table. SY. You can use SY kalau material ni ductile. What material you use? Cast iron, steel, AI, SI. So you tengok what is the yield strength value from the table properties. So safety factor of that yield strength over the stress or which one is critical. You identify in this member ABC which one is critical. So that means your component is safe. You have to identify which component yang along ABC yang critical. What type of stress happen? Itu later kita belajar lah. That's later. Tapi yang penting, the first thing is your free body diagram. So what about this one? Cepat sikit. We have a rod tadi macam ni. A, B, C and so on. So what is it? Okay, we have this pin joint. We have this roller on the slot. Okay, we have what we call not roller. This kind of we call a pin. It's a pin on the slot. So when the pushing, and there is a reaction from this pin on the slot. We can call this not pin, this kind of like a roller lah, but roller is fixed on this member. Tapi what type the reaction of roller to here, and this one is okay. So what is the free body diagram? Free body diagram ni apa? Macam mana?
X and AY.
So we have slot here. Okay. Okay, at A is what? A is what joint? Is it pin joint? Is A pin joint? Yes, right. A is pin joint, right? A is pin joint. So at A we have AY, AX. So what about B? Remember B we have a roller, right? So how many components there? You cannot simply everything is two component BY, BZ. You cannot solve. So you punya statically intermediate. You cannot solve it. It's a roller. So what is it? What the direction of the force? You remember this one P is pulling it. When P is pulling, okay. Remember the roller and the surface of the direction of the slot at an angle, right? At an angle. So we have component normal to that, this angle, a force, only one component. Like a roller on the surface. Roller on the surface. So on B, we have either this direction, we call it FB lah, normal surface. Okay. Can you hear? Guys, boleh nampak apa yang saya boleh nampak Kelas? Okay, at C, since we have external force, C, so we just have external force here at C lah. This only, we have P. Direction is X. So, FB, guys, can you see my video or not? So we have component. Okay, kalau if you make direction supposed to be downward, it's okay, no problem. The main important thing, the number, this is what we call free body diagram. Understand that, class? Okay, direction wrong, never mind. Do not worry. Direction, when you buat, you will get negative value. I mean, your punya ni will be reverse direction lah. Clear or not? Okay, tapi logically, it should be upward it is or downward? Logically lah, just to mention it. Is pulling and the direction from the pin to this wish surface. When this is pulling, logically it should be what? To the downward or upward? I'm not talking straight up, like this direction upward or reverse direction downward. This pulling, something this pin is holding on this slot. Which surface yang ada intact dengan the slot surface, the pin surface? Which side? The right side or the left side? Upper right? Logically.
Right side.
Aku susah juga nak fikir kadang ni bila terik ni. Terik yang mana kena dulu? Which one touch? This one is pulling. This one is pulling. Susah juga susah. Tapi tak, do not worry lah kalau direction up as I mentioned to you. Yang penting ini theta lah. Ni, the direction this is not perpendicular to here guys remember Yang mana? Okay, kita okay, right. Ni. Yang ni nampak ni. Ni last one ni. Boleh nampak kelas? Macam mana ni? Ni. Ni apa pula? Siapa yang baru join dalam e-learning ada figure semua in your e-learning. Saya nak besarkan ni macam ada ni kelas. Okay, ni macam okay, at B we have pin joint and C we have a rope. Okay, this is B, this one is C, ada rope, ada string or rope. At A, okay, A is A pin, okay, A tu apa? Pin joint ke roller? It's a roller, right? Kan? A is roller, B is A. Remember, nampak tak? That is a roller, a wheel or roller. Remember, kalau we roller, we only have one component. Guys, are you watching? Line tak putus? Line okay?
Okay.
Okay, so remember A is roller, only one component, only X direction because normal to the surface is vertical, right? So only one component. We have AX, okay, AX only. Okay, since the roller, the force acting on the roller is only AX and the roller acting at the pin, well, walaupun even this a pin joint, the roller and this member L shape is pin, since we only have AX only from the surface, so even this is like a pin, it's not a pin, just a roller juga, a roller lah, that's why we call roller. So only one component, AX only. Understand guys? Okay, at D here, we have a roller, but we have a pulley and rope. Pulley and rope, pulley and rope. Since our free body diagram together with the pulley is there, together with the pulley. If I make my sketch together with the pulley. So what is my free body diagram? What is my free body diagram? If you look, okay, free body diagram macam mana? Force reaction tu macam mana? That's called free body diagram. Okay, B is pin joint, right? Okay, B is pin joint. Okay, this B. So I have, remember, do not worry, direction B up or down, never mind. It's okay, nanti you can get the right direction. BX. C apa? Remember, attach a rope. Apa dia, guys? C apa? This not we call pin joint. It's the direction of the rope punya tension, betul tak? Tension. Class, clear or not? Class? Hello class, are you listening or not? Tension. Okay. What about D? Okay, sorry. Okay, at A dulu. A apa? Tadi saya cakap since roller, so we only have AX. Never mind, do not worry. Direction either to the right or to the left, it's no problem. Later when you fx0, fy0, you know your direction is supposed to be reversed. When you get negative value, I mean you reverse direction is positive. So at the apa, since it's tension, this one also tension. Tension is in line. Tension is fully in row. This one also tension, tension, and also this is a P. Here, okay, tension, tension. Actually, tension and P need the same value lah. Yeah. No, I don't call it, sorry. This is what we call P lah. If the amount of P is the force, this is what we call P. P. Okay, clear guys? Boleh Hello class? Alright, okay. Itu for your rehearse on your free body diagram. Can you watch the ni? Can you see my PowerPoint pula ni? Boleh Okay, that's what I buat ni. The reaction I already explained. Okay, another thing about free body diagram about this one yang ni. Can you see my PowerPoint? Boleh nampak this thing. Ni involve this kind of component. Draw the free body diagram. Ni for this member. Okay, A, B, C. Okay, draw the free body diagram. Okay. Okay, free body diagram it means that this guy, okay, macam ni, point dia macam tu. Dia when we okay, yeah, for part A, this is a component, they are a fixed support at this vertical plane, as the plane. We have a solid cylinder, fixed support at the vertical plane. Okay, only direction force in direction of Y. Okay, since this Y, X, and Z upward. We have Fy. So what is the direction of the other end of the rod? The end of the rod tu. Apa dia punya direction? In this case. Macam mana tu? Part A tu. Can you see my live video, my sketching? Nampak tak? Okay, A tu. Okay, A. So what is the direction? So, okay, since the direction is like this, this is Y, is X, and this one is Z, okay? So we have component Fy ni. So apa reaction at the other end? Opposite, yes. We have macam mana I label ni? Sorry guys. Yeah, Fy also lah. Fy reverse direction. Because we don't have bending moment, we don't have moment, we don't have torque. Okay, what about this A? What about B? B? If we take the free body diagram of the rod, it's a fixed support to that vertical plane. We have this one in tension. Just now in compression, this one we have Fy in tension. So what is the direction at the end? B, part B. Yeah, opposite lah, tension lah, Fy also. Okay, we don't have moment, we don't have torsion. Okay, C. Look at C. Are you watching the diagram in the PowerPoint? Yeah. Part C, be careful. Part C, what we have there? Part C, okay, we remove the rod from the vertical plate. So we have Fz. Okay, Z is vertical. Apa reaction that we have at the other end? Remove the rod from that vertical plate. It's a fixed support, guys. What do we have? Do we have Fy? No. Do we have Fx? Fx? Do we have Fx? No. Yeah. Fz also upward, right? Yeah? Yeah. One component that we miss. What is it? Still not enough. This is wrong. Okay, Fz is right, but one more component, very important that we miss. What is it?
Bending.
Yes, you are right. Let's say we give a distance. This is a distance D, right? Says we have Fz. When you look, okay, we look from this right side. So this is our rod, like this. So this is our vertical plate. Vertical plate is like that. This is our rod. So we have our Fz is downward, right? Okay, downward. This is a distance D. Okay, moment is force Fz times the distance, right? This, are you watching my live video? Can you see? Class? Hello, class. Okay, If we look from the right side view, so moment. So this FZ time, it produce moment of counterclockwise. Betul tak? Counterclockwise moment, right? Moment. Actually, moment is moment. Is it moment X? Is it moment Y? Or is it moment Z? The direction of that moment. I want to test your knowledge. What direction of the moment? Is it MX? Okay, just now you say, yeah, okay, you have MC. One more component that we mean is moment. We have moment. Because FZ time distance produce moment. Okay, if you look, FZ time distance, it produce this counterclockwise moment. But since we remove this rod from that vertical plate, okay, since it produce moment, right? So our moment here, should it be, we have a counter react. You understand what I mean? Moment. So we have FZ like this, and we have FZ yang counter react, because summation of Z must zero force, kan? We have a counter react moment. Clear or not? The moment should be counter react. Class, clear or not? But yeah, if you look together, yeah, FZ time the distance, it produce clockwise. If you look from the right side, if you record, but if you remove the free body, because this one have to be counter react moment. Moment is FZ times the distance. Okay, FZ times the distance. Okay, FZ times the distance is what is the direction of the vector of that moment. Remember that I told you that right hand rule? What is the direction vector of the moment? Is it moment X? Is it moment Y? Or is it moment Z? This is an isometric view. Remember the axis is like this. This is X. This is Y. This is Z. See, your moment, this end, your moment produce this direction. Betul tak? Moment produce this direction. My moment in what vector? Is X or Z or Y? Guys, can you hear me or not? Yeah, you are right. X. Moment X. Yeah? And tadi ni I just want to test you. Is it MX, MY, Z? It should be X, moment X. It's moment X because, okay, the answer you have, okay, you have FZ here, and you have, I cakap ni moment ni kena react. Moment is, and moment is MX equal to FZ times D. Guys, ada line putus ke apa? Kelas? Line stop, hold on. Oh, okay. Alright, okay. So it should be MX kan? Saya nak tak faham, tanya saya kenapa MX ni can WhatsApp ni. Faham tak? Tak, reaction is like this. But see it's like this. FZ downward, FZ plus the moment. Why? No sir, why is moment this clockwise? Yeah, because this one produce counterclockwise. At the end must be react, counter react moment. Should be like that. Kan? At the end it should be react. Pasal this one, because at the left end it go for counterclockwise, but on the right end, the other end it must counter, because summation of moment must be zero. Yeah, that one is for part C. Okay, what about D? Oh, sorry. D macam mana? D macam mana? Plus. Sama juga tapi terbalik. Plus. Are you watching? We have FZ. So what the other end? Come on. F, the other end? F. Downward. Z. So what F? Moment. Moment Y, moment X, or moment Z? Yeah, moment X or moment Y or moment Z. Yeah, moment X. Is it clockwise or counterclockwise? So this is D. It's the So yeah. Yeah, since this produce like this okay, this fz time distance produce negative x direction, right? So you're right, it should be counterclockwise. Counterclockwise. M X. Understand what I mean? Guys, kalau you confused, be careful about this thing. MX. Moment, force time distance is the force time distance produced. The way it twists to is your graph. Can you see my thumb? Boleh nampak ke thumb saya ni? Besar, tak nampak. Plus, the turning is right hand rule. The turning is the direction of you punya rotation clockwise. But your thumb is direction vector of your moment, guys. Yeah, direction is your thumb. Not the turning. The turning is not the direction of your torque or your moment. That is not the direction of vector. Vector moment is your thumb. If your moment turning like this, but the thumb pointing like this, it means the direction is negative x. If your moment is turning is like this, and direction of thumb that way, that is positive x, I mean that is mx. Mx either positive or mx either positive. Okay, in this case, it is, since this one, the f time distance produce direction negative, but at the end it must be counter. Counter it means go to positive. So this f positive, where you punya fz time distance lah, moment is fz time distance. Okay, that one is for D. Okay, what about E? E macam mana? Be careful. E, we have fx. Are you listening or not? E, we have, okay, this x, we have fx. So what about this n apa ni? Cepat sikit. Yeah, negative fx. Lagi. Okay, moment dia tu apa? Distance ni D, length ni D. Mx, okay. This fx time distance dia produce apa? Positive. Apa direction vector dia? Fx time distance produce what vector? Moment? Mz, My or Mx? Yes, Mz. Mz, force time distance produce Mz. This Fx time distance dia produce like this. They produce upward Z or downward Z. Okay, this one it produce no upward. But the reaction at the end, yeah, it should be downward. M Z. Clear tak guys? Faham tak? Pasal at the end ni dia kena counter tau. You jangan tak. You kalau buat nanti calculation of you punya moment nanti will be careful about it. Kalau you make it like this, no, pasal this is from the end. Because they always have to balance. Summation of moment must be balanced. So from this fx time distance, of course, yeah, you produce positive z. But at the end ni, macam like this one, if fx here is this word and fx at this end, they kena reverse to make it equilibrium. Same goes for moment. This one time the distance, it go upward z. But at the end, there must be react. Understand tak class? Class? Should go like this, mz, should be downward. Clear? So fx time distance. Nampak tak? Class, okay tak? Line tadi ada foto. Okay, clear or not? Okay, last one, F. Boleh nampak Saya punya sketch ni boleh nampak, live video saya nampak F, we have torque. For F apa? We have, okay. Tadi E okay. F ni we have like this. Nampak tak? Ni moment, that's why I cakap moment Y. Can you see moment Y? The moment Y. Pasal dia, because since our axis is like this. This X, Y, Z. X, Y, Z. So that's why ni moment Y. Okay, at the end dia ada apa? F, we don't have any force kan? Any Fy, Fz, Fx, no We only have moment. Atau we can call this torque lah, moment moment torque same force time distance. So what is the end here? What do we have? Yes, moment y, yes, you are right. Moment y but reverse direction lah, kan? Moment y, the same value but reverse direction. Okay, clear? Itu that's how. Ini benda ni, this is what we call free body diagram. You kena mahirkan tak boleh single mistake guys. Be careful lah. You cannot be single mistake. Okay, draw the free body diagram yang ni pula. Okay, tengok sini. Boleh nampak tak this figure guys? And then I'm talking about PowerPoint. Plus. PowerPoint ni. Draw free body diagram yang ni. Example 2.5 ni. Can you see? Ni. Ni free body diagram macam ni. Dekat section AA ni. Okay, dia ada fixed support ni. Kita tak go for at the shoulder. Betul-betul at the neck ni. Only at the section. No, the PowerPoint slide. Can you hear me or not? Hello class? Just now. The previous example that I show you. Okay, hold on. Yeah. Yep. Yeah. Can you see my live video? Yeah, the same line. Because in that we don't have SF, Fy, and Fz. We only have external moment My. And at the end here, it's supposed to be same My also, but reverse direction. Because summation of moment Y must be 0. That's equilibrium. Because summation of moment Y must be 0. Summation of moment Z must be 0. Summation of moment X must be 0. This is moment Y. Direction is Y direction. It's okay. This end, we have this direction. Right? This is positive Y or negative Y? Vector of moment. You're right. Can you see? Right hand rule. Your what you call it? Your finger wrap. Finger wrap is direction, the turning of your moment. Okay, at this end, it produce positive Y or negative Y? I mean left hand. Positive, yes. At the right end, it must be balanced. Direction of your moment must go to negative moment. So it's supposed to be like this. That's why you punya direction is like that. Is what you call it from here, we call it clockwise and counterclockwise. It should be like this. Clear? Abdullah, clear or not? That's why, because we don't have SY, FY, FZ, we don't have. We only have external moment, then direction is this is a pure moment, pure twist of this rod. No axial force, no vertical force, or any FX force. Okay. All right. Okay. What about this one? Ini. This one. Can you see this picture? Example 2.5. Plus. Okay. Okay, let's take section. You can see that is section AA plane. What do we have here? Okay, this is a little bit harder than previous one. That one is just a plain rod. This one we have angle. So what is the direction at AA? Let's discuss. What is the direction of that AA? Can you see my sketching class? Boleh nampak? Class? Are you watching or not? Sorry, line saya ni ada problem sikit lah line saya ni. Hold on. Okay, kelas line saya ni ada. Okay, nampak Kelas. Okay, that figure example 2.5 tu. Okay, we have, I make a section. Oh yeah, I just cut a portion. Section A. This is section AA lah. Not at the neck. Not at the neck. So we have this L bar. It's bending 90 degree. L bar. So we have force here. We have force. Straight. Okay, dia punya axis. Dia tak cakap pula which one. Okay, never mind. Kita put the axis here. kita put as okay, let's say kita go for XY analysis. Okay, this is X. Can you see my thing? This is what you call this is X. Okay, right. Kita ikut standard tadi lah. Macam ni. So this is X. This is Y. This one is Z. So force is like this. Okay, this one they have a distance B from here to here is B. Guys, kalau tak dengar apa-apa lain putus, inform me. Okay, section AA. Okay, section if we cut the portion AA, what do we have? Okay, we have, okay, this is what F this? F, this FZ right guys, are you listening or not? Ni FZ kalau based on my axis. Plus, can you hear me or not? Okay, FZ. Okay, what is the direction? We have FZ, okay, dekat sini of course we have counter lah. Betul tak? Section AA, section AA, we have same value lah, FZ, right? Guys, can you hear me or not? Alright. Okay, what else do we have? Yeah, we have from, okay. Let's look, tengok, listen carefully. Look from the left side view. Okay, my free body diagram like this. I got just like this, betul tak? Looking from the side view from the left. Left view, I have this cross section AA here. And I have my FZ here. Okay. So this FZ, we have a distance B here. Betul tak? B. So what it produce here? Dia produce apa ni? At this point, dia produce apa? This FZ produce apa? Dia produce moment lah kan? Or torque pun boleh, moment pun boleh. Moment lah, let's say, okay, sometimes you confuse what is that. Actually it's the same, it depends nanti. Torque, moment is, it produce moment, betul tak? This FZ time distance B is FZ time distance B. Okay, I want to ask you, what moment direction? Is it MY, is it MX, or is it MZ? Are you watching my live video ni? Okay, if you look at external moment is like this. Is it what? M apa ni? MY, MX, or MZ? Yeah, you are right. MY. Okay, dia produce. Kalau ikut isometric view dia produce what do it produce? Positive Y or negative Y? Based on the isometric view. Now, kalau you look from here, it is clockwise, right? Kalau clockwise like this, right? Clockwise. I'm talking about isometric clockwise. So it go to positive Y, right? So, all right. So it produce clockwise. So I'm talking this is a side view, right? Also, that is what you call MY. MY. You are right, MY. But as I mentioned to you, at the end here, dia kena counter. The answer is MY to counter react. Betul tak? You understand what I mean? This one produce clockwise. So here, it have to balance. Counter clockwise. MY. You understand or not? Clear or not? Where MY if FZ times B plus can you hear me? This MY where FZ times B. Okay, you are right. They produce from side B, you produce clockwise, but at the end, because summation of MY is 0. Since this one produce clockwise in terms of Y direction vector, this one must be reversed at the end because we are talking free body diagram because it got to be balanced. So MY, okay, is with FZ to be. Okay, FZ, okay, you reverse. Because this one downward, it go upward. Must be balanced. Yeah. Okay, that is we looking from the this left view. But when we looking from the right view, what do we see? What do we see? When we look from the right view, we have this L bar become like this, and we have this cross section of we have this FZ down the external force FZ. So this is our AA. This is our AA. Okay, hold on. The line putus lagi. Boleh dengar kelas? Can you hear me? Okay, alright. Okay, this is looking from the right view. We have FZ downward. So, okay, so we already have FZ upward. Kita already have FZ upward tadi. We already put the here already. We have here. Okay, we already have FZ already there tadi. Kita dah put. But another thing, from the right view, we have this FZ time the distance. Now it's not B. We have a distance A. This is section A. Can you see this is the distance A? From here to here. So this FZ downward times A, what moment it produce? It go to clockwise, right? What moment is that? Is it MY, is it MX, or is it MZ? FZ times A. It produce moment also. This view is looking from the right view. Are you listening or not, class? So they produce apa? Moment? M? Yeah, you're right. Moment X, right? Yeah, moment X. Moment X, where your FZ times A. Do not confuse which one come. Actually, this one we call it torque, guys. We call it produce torsion. Yang MY yang tadi actually is torque. Torque Y. You can replace M by torque. The same thing, FZ times this. We call it produce torsion to twist this. Yang FZ time A, it produce moment. This is what we call actual moment. Tapi never mind. Nanti you get confused. Actually the same. Okay, if you look from the right view, you see this view, this FZ downward. So we have yang ini also upward lah, FZ. Okay, we already put here lah in my isometric view. I already have Z just now. Okay, but we have FZ times A produce MX. Is MX. If some of you, mungkin certain of you maybe still get confused. Tu I cakap. Direction vector tu is this FZ. Okay, if you look back to the isometric, FZ times A ni, FZ times distance A ni, kan dia produce twist dia produce the twist like this. Kan dia produce like this, clockwise. Dia produce clockwise, if you look by time, dia produce like this, clockwise. Tapi it goes to negative X. The external FZ times A kan dia produce downward punya arah twist. The twist direction is downward. Right hand rule. The thumb is the vector. Do not confuse. This is not the direction of your moment actually. This is only the twist direction. The twist direction. The direction of your moment is the vector. This is the moment, not this one. But right hand rule it goes to negative X. This one, the external moment. But at the end, we get summation moment of X2 must be 0. So at the end tu, mesti reverse. Must go to this direction. Clear tak? Clear or not? So that's why kan, yang ini, so ini from this right view, dia produce clockwise direction. So at the end dia kena counterclockwise. So will be MX. MX is FZ times A lah. So yang ni tadi like this. So ini susah to make the sketch to you understand lah. I hope you understand lah. On this plane lah. On this plane, kita ada, I want to explain to you in terms of isometric. I hope you understand. MX is like this. It looks like it's the same. It's like this one in the, yang tadi MY ni on the XZ punya plane. Yang ini on the ZY plane. It's on counterclockwise. Can you see my confusion? Okay, ini MY tadi. Ini will be MX. I hope you understand lah. Ini plane yang sekat ni ZZ plane MX. Dia go to counterclockwise. Clear tak guys? Itu aja. Yang lain okey tak? Tak, benda-benda ni penting guys. Ini yang kalau tak faham tak payah, do not worry lah. You just take it slowly. Tapi this thing lah, kalau you mistake on this, nanti you punya, bila you tahu moment, you tahu force, then you can find the stress. For example, from here you can get the bending stress. Bending stress, this produce bending. Nanti I explain to you lah about stress. Maybe on the next class lah. I think today we stop here lah. I hope you understand about free relativity. Can from here then you can get what is the stress value. This one, you punya free body diagram. So my point is free body diagram kena betul. Must be right. Macam tadi I cakap, you explain tadi buat pin join. This just to rehearse, complete rehearse you punya knowledge from your static tu. Nanti you dah totally forgotten kan? You forgot to refresh balik. Tu fundamental tu, you must know tu. Pin join macam mana. This all thing will involve lah. You boleh check lah. Saya tak discuss ini. You can check in my e-learning. Ada banyak exercise you boleh tengok. How do I I don't want to discuss. I put in e-learning macam this one. Okay, if you can see my e-learning, boleh nampak kelas.
Can.
Macam ni dia cari what the reaction dekat this thing. You tengok this card, we have force analysis. Macam this equation, you can look at, jangan depend kat saya mengajar, okay, this equation, macam, ini is all from you punya solid mechanic exercise. Determine the internal load acting on the cross section through point D of member AB. Macam ni, at point D, you have member, nampak tak? You have link. Okay, even this thing nanti later on, nanti your test one, you maybe involved dengan shaft, bearing, tak. Tapi this thing is fundamental. Sometimes certain component members can be linkage like this, maybe in your project kan. So this is a fundamental. That's what is a free body diagram. Kalau okay, member A, D, B, this is BC, this is pin joint, this is pin joint, this one is still pin joint. Ni they want to know. At D ni, apa dia punya internal reaction dia. We have normal and V, shear stress and direct normal stress. Always kalau we cut, kita mesti ada this thing. So, itulah dia. Kalau if you look the solution, it's already there. Kalau tengok the solution I buat from that exercise, you follow the solution, the free body diagram. If you look on the free body diagram, okay, member ADD. So nampak the pin joint tu, okay, we have AY, AX. The point D ni kita, okay, we have external moment. Why? Because the question already given. We have external moment. It's given in the question. External moment 70 Newton meter. So in the solution there, I have external moment 70 Newton meter. And direction, this is the link. Nampak? Actually this thing at this joint, macam, okay, sir, since this pin joint, this is pin joint, why didn't I make it BY and BX? No need, you're wasting your time because you remember from your solid mechanics, it's a linkage, okay, you separate from this. Actually, you punya total force BC tu at an angle lah. It's much simpler to solve. Kalau you put BY, BX also can be solved, but it take harder for you to solve the reaction force. Macam ni is BY at an angle. We have 150 and 250. You can know the theta angle. So that's why, okay, in my solution there, okay, I know the just FBC lah, the member is 36.87 based on that vertical ni, FBC. So, okay, this FBC, everything is much simpler to solve it. So at point A, so just in matter of summation moment of A is 0, then we have external moment. So you look on ni, okay, first I make it summation of moment, then summation moment of A is 0 at point A, So I have external moment, so I cakap counterclockwise positive. So yang ni is clockwise negative. So I have hello class. Can you hear me? Belah. Saya kena mouse sebab tak bergerak ni, kenapa ni? Jangan ajar Okay, kelas, kita ada technical error sikit. Tak apalah, I stop it here. Kita continue. What is our next class? Can you hear me, class? Yeah. I stop it. Tapi before that, I need to restart need to go for your attendance. Hold on jap. Continue on the next class. I'm not sure. On what day is it? On the next meeting. Hold on. My computer hang. Hold on, for attendance. Yeah. Wednesday. Yeah, this one. Oh ya ke? Saya lupa lah. Yeah. Oh, okay. I'm sorry. This Wednesday public holiday. Kalau tak apalah, it's okay lah. Tak apalah, nanti next week kita kena fokus lah. Boleh next week tu compress sikit lah Pasal Wednesday tak ada kelas. The next class tu kita little bit, I'm rushing on something I hope you understand lah. To cover what we miss on Wednesday. Boleh? Kejap kelas boleh tak nanti rejoin for your attendance? Saya